Hi, I'm Azizat. So I built a clinic management system using Java and MySQL. So it's basically a backend system designed to manage patients, appointments, treatments, and billing, all structured through a relational database where every entity is connected and dependent on each other. So the main goal of this project is to simulate how a real clinic system actually works on the backend. So instead of building isolated features that don't really connect, I focus on how different parts of the system interact and link together, ensuring that every action affects the right part of the system. So overall, the system is designed to maintain consistency across multiple related operations. So for the tech stack, I use Java with JDBC for backend logic and MySQL as relational database. So I also follow the data access object pattern, which separates database logic from business logic. So this makes the system easier to manage, scale, and debug because every class has a clear responsibility. So let me quickly walk you through the structure. So we have model classes like appointments, patients, and treatments. So these represent the actual data objects in the system. Then we also have data access objects classes like the appointment DAO, patient DAO, and treatment DAO. So these classes handles all database operations such as the insertion, updation, deletion, and the retrieval of data so that the main application logic stays clean and connected. So there is also a DB connection class that manages database connectivity in one centralized place. And we also have a main class that controls the entire application flow. So before proceeding to run the application, let me quickly show the database structure behind the system. So here is the entity relationship diagram of my database. The diagram gives a simple overview of the tables in the system and how they are connected. First, we have the patient table, which stores patient information such as ID, name, age, gender, and phone number. So this is the main table used when registering patients through the patient access objects class. So a patient can have multiple appointments, which is why the patient table is linked to the appointment table through the patient's ID foreign key. Next, we have the appointment table, which stores details about each visit, such as appointment date and status. So this table is mainly managed through the appointment data access objects class when booking or updating appointments. Now, each appointment can have multiple treatments, which is why it is linked to the appointment treatments table. So this table shows the treatment name and cost for each appointment, allowing one appointment to have multiple treatments while keeping the database properly structured. So each treatment record is linked back to the appointment using the appointment ID foreign key. This part supports treatment handling within the system. Finally, each appointment generates a bill which is stored in the bills table. So the bills table contains the total amount and payment status for each appointment, and it is also linked back to the appointment table through the appointment ID foreign key. So overall, this relational structure helps maintain data consistency and keeps the database well organized. So now that the structure is clear, I will switch to MySQL and take a look at the tables directly. So first, I will select the database I'm working with, which is ClinicDB. So now that the database has been selected, next, I will display all the tables inside the database to confirm everything has been created properly. As we can see, we have 4 tables in the system: appointment treatment, appointments, bills, and patients. So this confirms that the database structure has been created successfully. So now I would like to take a closer look at each table structure using the describe command, starting with the patient table. This shows the structure of the patient's table. We have an ID field which serves as a primary key and is auto-incremented. Then we have the name, age, gender, phone field which stores the patient's personal details. Next, I will check the appointment table. This table contains an ID as a primary key and a patient's ID which is a foreign key linking each appointment to a specific patient. So it also stores the appointment date and status which helps track each visit in the system. So now I will check the appointment treatment table. This table stores the treatment linked to each appointment. It also has an ID as a primary key and an appointment ID which connects it back to the appointment table. So it also stores the treatment's name and cost, which allows multiple treatments to be recorded under a single appointment. Finally, I will check the bills table. This table shows billing information for each appointment, including the total amount and payment status, and it is also linked back to the appointment table. So overall, this confirms the database structure has been properly created and all relationships between the tables are correctly defined. So now that the database structure has been confirmed, I will run the application to demonstrate how the system works in real time. So when the system starts, it first asks the user whether they want to explore the system or not. So if the user selects no, the program terminates immediately. However, if the user selects yes, the system continues and displays the main menu. Now, this menu serves as the control center of the application. So it provides different options such as registering patients, updating records, deleting patients, viewing all patients, searching patients by ID, viewing patients history, booking appointment with treatment, updating appointment status, and viewing appointments, where each option corresponds to a specific functionality implemented in the system. So from the menu, I will start by registering a new patient. So the system collects the patient's name, age, gender, and phone number. So for demonstration purpose, I will create a sample patient's record with the name John Philip, age 25, gender, let's say male, and a phone number to simulate the real data entry into the system. So once submitted, the system confirms that the patient has been added successfully. Then, this data is sent to the database using a prepare statement and stored in the patient table. Next, I would like to book an appointment along with treatment for this patient. So I will enter the patient ID as 1, set the appointment date to May 17, 2026, and mark the status as scheduled. So after that, I will add the associated treatment. So in this case, 2 treatments will be recorded: a general checkup costing 8,000 and laboratory test costing 15,000. So each treatment is stored as a separate record in the database, but all treatments are linked to the same appointment using the appointment ID. So this creates a one-to-many relationship where one appointment can have multiple treatments. This is more realistic because in a real clinic, a single visit can include different services like consultation, test, or medication. So each treatment is connected to a specific patient in the system through a foreign key. This ensures that every appointment belongs to the correct patient, preventing data from being mismatched or left unlinked. Now I will move to the patient history feature. This part of the system retrieves a complete overview of a patient by combining data from multiple related tables, including patients, appointment, treatment, and bill. So instead of viewing each table separately, this method brings everything together into one unified result. So because each appointment can have multiple treatments, the SQL joins return one row per treatment. That's why the same appointment may appear more than once in the appointment, with each row representing a different treatment linked to that appointment. This gives a full breakdown of everything that happened during each visit. The total bill is calculated when the appointment is created. It sums up all treatment costs linked to that appointment. So in this case, 8,000 and 15,000 are added together, giving a total of 23,000. So that total is then stored in the billing table and retrieved as part of the patient's history. So finally, the system provides an exit option. So when selected, it terminates the program gracefully. So let's now move to the code implementation. So the DB connection class handles all database connection setup in one unified place. So instead of repeating connection logic over and over again across different classes, whenever any data access object class needs to interact with the database, it simply uses this connection, which also makes the system easier to maintain and debug, because if anything changes, like database URL, username, password, or any other credential, I only have to update it once and it reflects everywhere. So this is patient DAO class, and it handles everything related to patients in the database, like registering new patients, deleting them, updating patient details, viewing patient history, and so on. So for example, this method is responsible for inserting a new patient into the database, and the data is inserted into the database using a prepare statement. So the main reason I use prepare statements here is because they make the system much more secure. So basically, instead of directly building SQL queries with user inputs, the input is handled separately. So this helps prevent something called SQL injection. That's when someone tries to mess with your database by typing in harmful SQL code through an input field. But with prepare statements, that kind of input just gets treated like a normal text, so it can't interfere with the database query. Prepare statement keeps the system safe and a lot more reliable. Now, one of the most important parts of this system is the transaction logic. To handle the full appointment process properly, I used database transaction. So instead of saving each step immediately to the database, I disable auto commit first, which gives me control over when the changes are actually saved into the database. Then all operations are executed step by step. So if everything runs successfully, meaning the appointment is created, treatment are added, and all the bill is generated correctly, then I commit the transaction and all the changes are saved permanently as once. But if everything fails at any point in the process, I roll everything back. So it's basically an all or nothing approach, which prevents partial data from being saved in our database and keeps the database consistent. Now I'll move to the patient history feature. So this part of the system brings together a complete view of the patient by combining data from related tables such as patient, appointment, treatment, and billing. So instead of looking at each table separately, everything is merged into a single result for easy understanding. Since one appointment can include multiple treatments, the SQL join produces one row for each treatment. That's why the same appointment may appear more than once in the output. So each row simply represents a different treatment linked to that same visit. So overall, this gives a full breakdown of everything that took place during each patient visit. So the main focus of this project was ensuring data consistency across related tables in the database. However, during implementation, I encountered a key challenge. So one issue was making sure that multiple related database operations are executed together without causing inconsistency or partial updates. So to address this issue, I took a structured approach. So I designed the database using proper relational principles and connected the tables using foreign keys. So I also implemented JDBC transactions to ensure that all operations within a process either complete successfully or are fully rolled back in case of error. Overall, this project reflects my ability to design and implement a structured backend system using Java and MySQL with a focus on data consistency, relational database design, and safe transaction handling.